some sort of delay, some sort of delay. Some sort of delay. Right, can hear myself now. That's a good sign. We'll jump straight into it. But first, it's a bit of a contradiction, isn't it? Now, hopefully someone can, oops, join us live. So I'll just share the stream link to both Twitter, keep calling it Twitter, just to annoy some multimillionaire. I don't actually use it. Just post and run. And then we mainly use LinkedIn. If you want to connect on LinkedIn as well, do let me know. Just add me to your network. Join in a live development session that's been posted. I have some prompts and stuff. We loaded the code into GPT-4. Yes, the script does handle various functionalities like managing the audio context, loading a piano instrument, fetching EEG data, plotting the EEG data on the chart, converting EEG data to MIDI notes, and playing the sequence. So one more information on this one here. Converting EEG data to MIDI notes. Yes, data collection, data processing. In your code, load data, frequency analysis. Okay, so the EEG data typically in the form of time series voltage values. To convert this into frequencies, you might need to perform a frequency analysis like a Fourier transform. However, in your application, it looks like the EEG data is already in the frequency-like format, which I don't think is true. Scaling, routing to nearest MIDI node. Yeah, it's not in the frequency. I know it because when we actually use it to see which code is actually being invoked. But essentially, currently we're loading channel 0. And the nodes, the frequency translation is just, it's essentially amplitude modulation, where the frequency value is going up with increased amplitude, which is a bit odd, but that's, I guess, just was a template code. Because, for example, if it just to illustrate how it works, let's just select channel 7. We listen to the notes generated. Right, so you could see it's going the frequency, the note frequency. So we're having a higher frequency note with increased amplitude. That's quite obvious, so you don't need to be a musician to be able to tell that. So the issue is that this is saying that it looks it's already converting into frequency. There's actually no FFT done, pretty sure. Let's double check. Yeah, we're using a linear interpolation, so where this thing is actually not being used. Why not? There's some sort of, I'm just using interp from NP, which is numpy. That function is actually the SciPy interpolator is not being used. So the problem is with this EEG frequencies. Let's search for them. It's already in EEG data. How so? Data 0. The EEG data is not the frequency, it's actually the time. Can explain. So we'll ask both GitHub Copilot. Where is it? Copilot. Explain this. And GPT-4 has all the code. So I'll ask it to do the same. Let's read GitHub Copilot. Yeah, variable. It doesn't have context. In the context of your project, a list, dictionary, data structure, it could also function as a class, blah, blah, blah. Yeah, GitHub Copilot gives something super generic, not very useful. Let's see what GPT-4 got to say. Now we ask you specifically. Okay, so we need to ask about the code. In this code, how converting EEG data to MIDI notes is performed. Yeah, we're extracting EEG. We are converting EEG to music function. With GitHub Copilot, while GPT-4 is generating, let's try to explain the whole code just so it has the context. Oh, my assumption is that those frequencies are not actually frequencies, because it's not, I don't know where, I don't remember it doing FFT or anything like this anywhere. Let's read this quickly.
Extracting EEG frequencies and scaling to MIDI range. Convert EEG to music route in the flask app is responsible for this conversion. It first loads the EEG data using load_data, start, count, channel, which returns the EEG data for a specified segment, defined by start, count, and channel. The EEG data typically consists of frequency values. These frequency values are extracted from the loaded data. EEG_frequencies equals data 0 for data in EEG_data. The extracted frequencies are then scaled to a MIDI range using the scale_EEG_MIDI, EEG_frequencies function.
Well, okay, the problem is those are not frequencies, those are amplitudes. So I wonder what it will do if I put this with 2 question marks.
I apologize for the confusion in my previous explanation. In the context of EEG, electroencephalogram, data, the term frequency usually refers to the rate at which the electrical signals are oscillating, which is measured in hertz, H said. However, the raw data from an EEG typically consists of voltage values over time, not frequency values. These voltage values represent the electrical activity of the brain.
Okay, so why are you treating them as frequencies?
In your application, the process of converting EEG data to MIDI notes seems to be based on these voltage values rather than on specific frequencies of brainwaves. Here's a corrected explanation of how the conversion is done.
It's good it's corrected itself. Might be tricky if you haven't used the EEG before.
Extracting EEG voltages. The EEG data loaded by the load_data, start, count, channel function is in the form of voltage values over time for different channels. The function convert_EEG extracts these voltage values from the EEG data. EEG_data equals load_data, start, count, channel.
Okay, what about scaling? Let's read this again quickly.
The EEG data loaded by the load_data, start, count, channel function is in the form of voltage values over time for different channels.
Yeah, convert EEG, extract voltage values. Okay, then we're scaling voltages value to MIDI range.
The function scale_EEG_MIDI, EEG_frequencies, where EEG_frequencies is actually a misnomer and should be something like EEG_voltages, takes these voltage values.
I like misnomer. Okay, so if it's a misnomer, why did you generate this code to begin with?
It scales these values to fit within a predefined range of MIDI note numbers. This scaling is done using linear interpolation with NumPy's interp function. The voltage values are mapped to a range of MIDI note numbers, e.g., 48 to 84 in your code, corresponding to C3 to C6.
Right, so we want this as a prompt because we want you to actually fix this.
The resulting MIDI note numbers can then be used to generate music, which is a creative way to represent the EEG data's patterns in a musical format. The actual musicality of the output depends on how these MIDI notes are used, for instance, the duration, rhythm, and the instrument used for playback.
Yeah, so if the function scale EEG to MIDI EEG frequencies, where EEG frequencies is actually a misnomer and should be something like EEG voltages, shall we update the code? Absolutely. Yeah, but I'll just update the name. So this function is taking EEG voltages, and we know it works okay. So for example, if I take another channel, any channel, play this sound. Yeah, so it is treating, as you can obviously tell, it is treating the amplitudes as frequency. Try another channel, and this is what we need to change. Just wondering if we should leave this as an option, as a amplitude modulation music option. I mean, first because it's already there and it kind of works generating music kind of based on the amplitude of the signal. This is another channel. Yeah, so you can see these three were the same. Just kind of works, it does something, not very useful. Also expect the seizures in the middle of this file as well. I have seizures, so we'll have much higher variability. But try clicking on that without it generating multiple times. Yeah, there's a problem with this code that when we scroll using the data position scroller, it registers more than one value. So that's another something we need to fix. The GitHub Copilot doesn't seem to get the context, get the mistake. What did we ask GPT-4? So we can ask if a load data function just ask an open-ended question. What load data function returns? Because in the code it assumes frequency is being returned, but it's actually amplitude, so it needs to be corrected. Yeah, GitHub Copilot says load data function returns a list of lists. Each inner list represents a row of EEG data and contains two elements, the EEG reading from the specific channel and the corresponding time in seconds. The function returns specified number of these rows starting from a specified start point, the channel from which the EEG is taken. So the question is it returning frequencies? The answer should be no. It does load data function return frequencies. And it should be no, even though the code assumes so. No, function does not return frequencies, return the EEG data from the specific channel. Yes, it's voltage values, not frequencies. The conversion to frequencies or any other form of data would need to be done separately. So where is conversion to frequencies being performed? Well, it's nowhere in this code. There's a separate function for this. Yeah, it's not done in the code, that's correct. Yeah, taking what's called EEG frequencies but actually representing voltages, that's correct. And scales these values to a range. This is not a conversion to frequencies in the typical sense. If you want to convert the EEG voltage to frequencies, you would need to perform a Fourier transform or a similar operation, which is not present in provided code. Please note that the conversion from voltages to frequencies in EEG data is a complex process, blah blah. Yeah, of course it is. We still need to do it. So instead of this prompt here, where it's obviously just suggesting to correct the names, we want to actually update the code to perform to add a conversion to frequencies. How to add code and ask the Copilot the same question. So far I didn't have much luck with GitHub Copilot. That's probably because I don't know how to use it. It is geared towards more experienced programmers. Right, so it's writing some convert to frequency, apply 50. I assume it's using to know what's the difference between R FFT to FFT. Might go with GPT-4 suggestion. I mean, GitHub Copilot meant to use GPT-4 anyway, but for some reason it gives you different functions. Can I at this stage I trust the OpenAI interface some to some larger extent? But we need to get this correctly, so might as well read the whole lot.
To add a conversion from EEG voltage values to frequencies in your EEG to music application, you'll first need to decide on the method for converting these voltages to frequencies. One common approach is to analyze the EEG signal in terms of its frequency components using a Fourier transform, such as the fast Fourier transform, FFT. This method decomposes the signal into its constituent frequencies and is particularly useful in EEG analysis. However, it's important to note that converting EEG voltage values directly to musical notes, frequencies, might not always yield musically coherent results, as EEG signals do not inherently align with musical scales. The conversion might need creative adjustments to make the resulting music aesthetically pleasing. Here's a basic outline of how you can implement this. 1. Add a function to compute frequencies from EEG data. You can add a function that uses FFT to compute the dominant frequency in each segment of the EEG data. This function will be called from your convert_EEG root. Python, copy code import numpy as np. Def get _dominant _frequencies, EEG data, sampling rate, dominant frequencies equals, for segment in each.
Yeah, sometimes it's reading the text to speech, is actually reading the code. Sometimes it isn't. But we get the gist. The question is, it's finding one dominant frequency for the whole segment, is it? I have to check. No, it's doing frequencies So what's the segment size? Where is segment coming from?
In your Flask root, call this function to get the frequencies and then convert them to MIDI notes.
There's a question for amplitude between delta, bit theta, up to 40 Hertz. You want to match notes. Yeah, I do want to match notes eventually. Well, we'll start with some sort of linear interpolation, but eventually, yeah, we try and find some more creative way of a more creative transfer function. So it's actually, it sounds more like music. So yeah, at the moment the template just does basic amplitude to frequency conversion. So the higher the amplitude is, the higher frequency note. But yes, but now we're turning it into frequency, an actual frequency conversion. So at the moment it just does. Yeah, so that's the template that originally gave, and now we will convert it to actual frequency. I think one of the main problems will be what type of window size. So the EEG data should be the data displayed on the chart. Currently it's only the 16 data points. Default is 100. This data is very long, so there's no shortage of data. Also, this data sampling rate is 400. So I don't know if that, how to use that information when converting to music. Any suggestions are welcome. So eventually this tool, the idea of it is to have, so you could scroll through pre-recorded EEG, choose your channel's window size, and then potentially additional controls will be selecting your segment size. So essentially, or just have it fixed. So for example, each window will be divided into whatever 10, and then have 20 or 30 as your minimum window size. So for every 30 data points, you'll be getting half the notes, the musical notes. Or yeah, you need at least, how many do you need to calculate FFT? Minimum of, well, I would say probably like 10 or something. So yeah, if we're going by default, so for every 100 data points, we should generate about not more than 10 musical notes. Essentially, when you load the page, reload the page, default goes to channel 0, 100 data points, 0 position in the file. There are seizures later, so will it start playing? No. Yeah, there's another buggy thing that if I actually use the data position scroller, it registers it as if I clicked twice or more than once. It's repeating the same thing twice. Which you could do possibly with a different musical instrument or something. So the other thing, that other channels could then be different musical instruments. So you'll need 16 of them. in this case. So we have our frequency. We'll leave this prompt for now, just save the chat later. So any suggestions of how to do it are more than welcome. Essentially, we want to hear what the seizures sound like. And yes, it's highly biased because you can essentially make them sound anything you like. So we're adding this, so we already have numpy as NP. So we have this dominant frequency. Question is, where's this segment coming from? Because we don't have it in the code. So we should have all our functions at the bottom. We already have numpy as NP loaded. This segment coming from segment. But just taking the EEG data. Don't quite get it. Let's read this quickly.
In your Flask root, call this function to get the frequencies and then convert them to MIDI notes.
So now in convert EEG, it won't work well. Convert EEG, have EEG data. Right, so this is EEG voltages, not EEG frequencies. Then we have this bit. Let's double check, triple check. EEG frequencies. This is the sampling rate. It should be 400. It's actually like 399.9 or something, but yeah, rounded up. It should be fine. Then we have MIDI numbers, yeah, using EEG frequencies. And we're returning conversion successful MIDI numbers. Yes, should this be should have global, should this be a global variable? Let's make this global. Right, convert to EEG. It's global. What else?
Modify scale _EEG _ MIDI to handle frequency data. The scaling might need to be adjusted depending on the range of frequencies you're expecting from the EEG. sampling rate, fs, ensure that the sampling rate, fs, used in the FFT matches the actual sampling rate of your EEG data.
Yeah, we made this a global variable, so that's fine.
Windowing, the FFT is applied on segments, or windows, of data. Decide on the size of these windows based on your application needs.
So what's different between segment and window? Segment. Yeah, it's only used in getting frequencies.
Musical mapping, the direct mapping of EEG frequencies to musical notes might not be straightforward. You might need to creatively map these frequencies to a musical scale or use some form of quantization to fit them into a musical context.
Yeah, how do I? That would be a big thing, wouldn't it?
Performance considerations, FFT and frequency analysis can be computationally intensive, especially for large datasets or real-time applications. You might need to optimize your code for performance.
Yeah, currently I'm using I only have one note, one musical font, grand piano. But yes, I want to try others as well, like bass guitar would be really nice for seizures, I think, or I don't know if it will sound more like drums or something. Let's save this. This wouldn't work, would it? So do we need to scale differently? Any suggestions for scaling EEG to MIDI? So that would be the range of the notes, I think.
To modify the scale _EEG_MIDI function to handle frequency data, you will need to consider how the range of EEG-derived frequencies maps onto the MIDI node range. Given that EEG frequencies typically range from around 0.5 Hz to 70 Hz, covering delta, theta, alpha, beta, and gamma waves, you should decide how to map these frequencies to a musical scale.
The other thing is we could map different instruments to different bands. That makes more sense, doesn't it?
A common method is to scale the frequencies logarithmically to match the way musical pitch is perceived. Here's an example of how you can modify the scale _EEG_MIDI function to handle frequency data.
Right, so that's the frequency to number conversion. Yeah, frequency below 0, yeah, obviously. Otherwise, yeah, we're already doing that. A logarithmic scale. Now with scaling, it's the scale function. Yeah. So returning median numbers, that's okay.
A common method is to scale the frequencies logarithmically to match the way musical pitch is perceived. Here's an example of how you can modify the scale _EEG_MIDI function to handle frequency data. Frequency _MIDI number converts a frequency value to a MIDI number based on the formula for calculating the pitch of a musical note. MIDI note 69 is standard A4, 440 Hz. and each increase by 1 represents a semitone up. Scale _EEG_DA_MIDI, EEG frequencies, converts each EEG frequency to a MIDI number using frequency_DA_MIDI number. It also clamps the MIDI numbers to a valid range, 21 to 108 for a standard piano. This approach assumes a direct mapping from frequency to pitch. However, EEG data's musical translation might not be straightforward due to the non-musical nature of EEG frequencies. You may need to experiment with different mappings or scales to achieve a musically coherent result. Additionally, consider the implications of mapping very low or very high frequencies, as they might fall outside the range of human hearing or the range of MIDI notes.
Yes, we need some sort of, for the last point there, we need some sort of range calibration. So the edge cases. Let's try this one. We have this function twice now. This is where it's being used. Comment this out. And let's test this, see what we get. Just randomly select channel 10. Get a 500. Tuple index is out of range. I think we want to see how large is that MIDI numbers array. How many notes are we getting to the conversion?
The error message, tuple index out of range, suggests that there's an issue in your convert_EEG function where it's attempting to access an element of a tuple that doesn't exist. This is often due to mismatched data structures or incorrect assumptions about the size or shape of the data being processed. Given that the error occurs in the convert_EEG function, we should examine the lines of code where tuple indices are used. The most likely culprit is in the processing of the data returned by load_data, start, count, channel. Here are some steps to troubleshoot this issue. Ensure that load_data is returning data in the format you expect. Print out the structure or length of the data to verify it matches your expectations. Add validation or error handling to check the structure of the data returned by load_data. For instance, ensure that the data is not empty and each element of the list has the expected format.
Now loading of the data should be fine because it was working before. But yes, we could use a more debugging. Right, first 5 elements EEG data.
Make sure that the get_dominant_frequencies function, or any similar function you're using to process the EEG data, handles the data correctly and aligns with the structure of EEG_data.
Normally good at solving this type of problems. I don't know, I made a wrong assumption about the structure of the data.
Based on the sample data you provided from the convert_EEG function, it appears that EEG_data is a list of lists, where each inner list contains two elements, a voltage value and a timestamp. The error, tuple index out of range, suggests that the code is expecting a different structure somewhere in the process. The error might occur where the code tries to access elements from each inner list in EEG_data. If the code expects a different structure, like a tuple with more elements, this could cause the tuple index out of range error. Given your data structure, you should ensure that all accesses to EEG_data are correctly indexing into these inner lists. For example, the line EEG_voltages equals data 0 for data in EEG_data is correct for extracting the first element, voltage value, from each inner list. Ensure similar correctness wherever EEG_data is accessed. The function get_dominant_frequencies, or any function you use to analyze the frequency content of the EEG data, must handle the data structure correctly. Ensure that this function expects and correctly processes a list of voltage values. If it's designed to work with tuples or different data structures, it needs to be adjusted. This will help you verify that EEG_voltages is correctly formatted before it's used in a frequency analysis. Make sure your error handling in the convert_EEG function is capturing the full traceback of the exception, which can provide more context on where and why the error is occurring. You can modify the error print statement to include traceback information. Given that the EEG voltage sample is correctly formatted, it seems the issue lies further down in the convert_EEG function, possibly in the get_dominant_frequencies function or its subsequent use. The error message, tuple index out of range, usually occurs when trying to access an element in a tuple or list that doesn't exist, so the problem likely lies in how the data is being accessed or processed in these functions. Ensure that this function correctly handles a list of voltage values. If this function expects a different data structure or if it's manipulating the data assuming it's a different type, like a tuple with more elements, that could cause the issue. Double-check how indices are accessed within this function. If there's any place where it's assumed that the input is a tuple or has more elements than it actually is, that could be where the error is occurring. Add print statements inside the get_dominant_frequencies function to understand how the data is being processed and to check if and where it fails.
scale EEG to MIDI function. It's the get dominant frequencies. FS is correct. So how does this work? What will be the value of segment? Let's do that quickly. Probably some proper Python development screaming at me right now. It's a problem that segment, isn't it? Get how this works. Regen get dominant frequencies function. Now that you know what the problem is,
To regenerate the get_dominant_frequencies function for your EEG to music Flask application, we will focus on extracting the dominant frequency from each segment of EEG data. We will assume each segment is a list of voltage values, and we will use the fast Fourier transform, FFT, to analyze these values and find the dominant frequency. This function will then return a list of dominant frequencies, one for each segment.
Okay.
Analyzes the EEG data to find the dominant frequency in each segment. EEG_data, list of EEG data segments. Each segment is a list of voltage values.
But what we currently have doesn't work, so we might as well get rid of it. We already have enough bias and B.
Segment size. This function expects each segment of EEG_data to be a list of voltage values. If your EEG data is structured differently, you might need to adjust the function accordingly.
So you know what the EEG data is structured like. There are no segments in the data. Explain this for segment in EEG data. There's no segments in the data.
EEG_data structure. The EEG_data is expected to be a list where each element is a segment of EEG data. A segment, in this context, represents a series of EEG voltage readings over a specific time interval. For example, if your EEG data is sampled at 400 Hz and you're analyzing 1 second segments, each segment would contain 400 voltage values.
Yeah, but is it 1 second segments?
Looping over segments, the for loop iterates over each of these segments. In each iteration, the variable segment is assigned to the current segment of the EEG data being processed. Within the loop, each segment, a list of voltage values, is processed individually. The typical processing involves applying a fast Fourier transform, FFT, to this segment to analyze its frequency content. The FFT transforms the time domain data, voltage values over time, into frequency domain data, showing the different frequencies present in the segment and their respective amplitudes.
Quickly. Takes too long. Segment is a one number. Obviously it doesn't work. Wondering why it doesn't understand the context of why it doesn't work and how to solve it. Why did you suggest this code to begin with, considering it was working?
Based on the output you've provided, it seems the error might be arising from a misunderstanding of the structure of the data being processed in a get_dominant_frequencies function.
Yeah, that's right.
The output segment, 70.0 inches, suggests that each segment being processed in the function is actually a single voltage value, rather than an array or list of voltage values, which is what the FFT function would require. This misunderstanding can arise if the EEG_data being passed to get_dominant_frequencies is a flat list of voltage values, whereas the function expects each segment to be a list of voltage values over a time interval. Ensure that get_dominant_frequencies is designed to handle the structure of EEG_data correctly. If EEG_data is just a flat list of voltage readings, you need to modify how the data is segmented before applying the FFT.
Right.
If the
Okay.
EEG data is not already divided into segments, you need to divide it into appropriate segments before applying the FFT.
Yep.
For instance, if EEG_data is a list of 100 voltage readings and you want to analyze it in segments of 10 readings each, you will need to create 10 segments each containing 10 readings.
Okay, let's do this.
Here's an example of how you might modify the code to handle this.
This makes sense. Segment size is 10. So we're dividing each window into 10 segments. Data. EEG data is what loaded on each screen. We'll check it in a sec. It's just turning it into a NumPy array, isn't it? Yeah, convert to NumPy array. We'll leave that comment there. Loop through each segment. Okay, that's clear. Why is it in? Don't quite get the 4-segment EEG data. Okay.
EEG_data is divided into smaller segments, each of size segment_size.
So in theory, we should have 10 nodes coming out of this. If it works. Still out of range. Segment, it's still 70. Write the whole. Yeah, write the whole function. Obviously not able to integrate it myself. Right, so just have the one for loop. Makes sense. It's kind of easy to tell there's someone else after the bot have done this. Yeah, I might continue next time. See you in a bit. Bye.